Alrighty folks, welcome to lesson 1.5 with dimensional analysis, and this is the strategy used to convert between different units. So as we talked before, and I think lesson 1.3 when we're talking about scientific measurement, we said that units were a scale used to kind of measure a certain quantity in a measurement. So, for instance, if I have something like length, right? Length is measured by meters. Right? Or in America, we call it inches. Right? Or if you have something like time, you can measure something in seconds or in days. So, dimensional analysis kind of helps chunk between different units to measure the same quantity. So, for example, if I am talking about 1 day, I can say 1 day can be measured in 24 hours, right? And hours is a unit. I could also say that there are 1,440 minutes in 1 day. Right? So minutes is a unit. And I also could say that 86,400 seconds could be measured in 1 day. And seconds is units. So how do I get these numbers, right? 1,440 and 86,400. So, dimensional analysis deals with kind of making relationships with these units and then setting them up as ratios called conversion factors, which we'll talk about in this lesson. So I know that in 1 day there's 24 hours, in 1 hour is 60 minutes, in 1 it is 60 seconds, and then I can set them up as fractions, right, as conversion factors, and then multiply and divide to get 86,400 seconds per day. So right now it looks kind of confusing, but we're going to dive in and figure out how do I set this up with dimensional analysis. So there are a couple things in vocabulary we need to know. There's something called an equivalent statement, right? And what that is that you relate the same amount in quantity in two different units. So if I have 2.54 centimeters, right? It's the same thing as 1 inch. So let's say I have my ruler, right? Okay, so right here from 11, if you see it, from 11 to 12 is 1 inch, right? But if I flip it down right here, right, it turns out to be something like 2.54 meters, right? It's directly parallel to 1 inch. So as you can see, it's the same quantity, right? Just measured on two different scales. They're the same exact quantity. So I can write these equivalent statements as conversion factors, which just puts them as a ratio or a fraction. So I can write 2.54 centimeters over 1 inch, or 1 inch over 2.54 centimeters, because I know that these equivalent statements are equal to each other, and that since they're both the same, they're both going to equal 1. Okay? Because it's like saying if I have 100 over 100, right? These are both the same in quantity. Okay? They're both equal to 1. So therefore, that's why I can write it either in this format or this format, right? It's the same value that can kind of flip around. Alright, so let's look at the strategy of how to convert between different units. Alright, first, you're going to start with the unit that you know, and then we're trying to figure out the unit that we don't know, right? The known and the unknown. And there are 3 ways to kind of organize it and look for what we're trying to find in the question. Okay? First, what do I know already? Alright, so that is the units I want to underline. Second, what do I want to know? Those are the units that I want to circle. And third, how can I get there? How can I use my equivalent statements to kind of set up my ratios to find the unknown unit that I want to find? Alright, so for example, a new baby weighs 7.8 pounds, and what is its mass in kilograms? So, what I would do as I'm doing this problem is I'm first going to underline what I know, right? So I'm going to underline what I know. Then I'm going to circle what I don't know. So this is the unknown. Okay, meaning that I want to convert from pounds to kilograms. Okay. Let me try that. Alright, so to convert, there are a couple things you want to look for in certain patterns. We want to refer to equivalent statements, okay? So that is when I know whether there's something in pounds, right? How many pounds of something is equal to the same amount in kilograms? And then I want to write them as conversion factors, those ratios, right? Those fractions when solving. So the units I want to cancel go on the bottom, the denominator, and the units I want to convert to go on to the top, which is the numerator. And then we're going to cancel out the units diagonally. So let me show you what that means. And make sure you guys write this down as well. Okay, this is a good reminder about how to solve these type of problems. So, alright, we underline what we know. We're going to circle what we don't know. And this right here is our equivalent statement. So, I know that in 1 kilogram is the same thing as 2.205 pounds. That is my equivalent statements. Okay? Now, I'm going to start off with what I know. Alright, this is what I know. Okay? And now I'm going to multiply it times my equivalent statement converted to a conversion factor. So that is when I write it as a ratio, right? I write the equivalence factor as a ratio. So I write the units I want to cancel out on the bottom right here. So I want to convert from pounds to kilograms. So, okay. So you want to cancel pounds, right? And I want to convert to kilograms. Okay, so I want to change from what I know, right? Cancel what I know, and then find what I don't know, right? I don't know what it is in kilograms. So, I cancel out there, cancel right there, right? Think of these units as like variables when you have when you were doing algebra, right? So, for instance, if I had like 2x divided by x, right? I cancel out x and x, and I'm left with just 2, right? That is my answer. So, same thing here. Right? I cancel out the pounds and pounds, and I'm left with only kilograms. So what I just do there is 7.8 times 1 divided by 2.205, which gives me 3.5 kilograms. Alright? So,